Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In this video, we're talking about fatigue loading on tension joints. Okay, fatigue loading on tension joints. So, this book content is taken from the book Shigley Mechanical Engineering Design, and the pictures here in this book is taken from this book itself and Google Images. So fatigue loading on tension joint. What is a fatigue loading on tension joint? Okay. So fatigue loading on both subject to fatigue action can be analyzed directly by the method of chapter 6, table 816. List average fatigue stress contraction factors to the fillet under the bolt head and also the beginning of threads on the bolt shank. Okay. Talking about fatigue loading. What is actually about fatigue loading? Okay. Fatigue loading is a loading given by cyclic load. In engineering language, it is called fatigue loading. It is engineering language. It is called also by the fatigue loading is caused by cyclic loading. Okay, what does it mean by that? In the layman terms, okay, the term that you use every day, that you observe every day. Imagine your chair that you are sitting right now. Okay. Imagine your table that you use right now. Imagine your bed that you sleep just now. Okay. All this. Okay. Let's say the chair. This is a chair. Okay. The chair has four legs. Okay. In the chair. 1, 2, 3, 4. Okay. So each of the leg has a bolt connected to it. Okay. And when you sit on this chair, okay, when you sit on this chair, you are giving a load. Okay. And then when you stand, the load is no more. And then you sit, it is you giving a load again. And then when you stand, you are not giving a load anymore. Okay. You stand and sit many times. This is called cyclic. Okay. Cyclic. Let's say this is the load, and then no load. Okay. No load. When you sit, you give load. Where you stand, you are not giving the load. This happen all the time. This is called cyclic loading. And what happened to the box, and what happened to the wood, to the chair, to the all the things that you calculate. For this case, or for this topic, we are talking about the bulb. And then this bulb is beginning to become fatigue. In a long time, the damage may happen to the bulb itself. Okay, this is what we want to study today. The fatigue loading on tension joint. Okay. Okay, this is table 816. Fatigue stress concentration factor for the thread element that we have learned before. The fatigue stress on the thread element. This is the thread element. Okay. This okay, for this part, this is not the threaded element because it is a grip. Remember, I always tell what is the difference by the grip and what is the difference by the grip that engineering term and the grip by layman's term. Okay. This is the threaded part. Okay. So this is the fatigue stress concentration factor for the threaded element for SA grade, metric grade, road threads, cut threads, and fillet, and the endurance strength. Use of roller threads is predominant method of thread forming in screw fastener. In thread rolling, the amount of cold work and strain handling is unknown to the designer, therefore fully corrected, including KF. Okay, axial endurance strength is reported in table 18.8.17. Since KF, it is axial endurance, is included as endurance strength, it should not be applied as stress increaser using values from this table for the cut thread mentioned in chapter 6. are useful and anticipate the endurance strength will be considerably lower. What is an endurance strength? Okay, what is an endurance strength? Like yourself, when you are going for jogging, okay, you, if you compare to your athlete, athlete has more endurance than you, okay. um, they are better trained and they have more endurance than you, okay. The same goes for the boat, okay, meaning that given for a long period of time, whether this boat can withstand or cannot withstand the continuous loading from cycle. Imagine the chair that you are sitting right now, okay, imagine the table that you are writing right now, okay. Imagine all the things that being being given force again and again and again. The motorcycle tire, the uh, the load on the your motorcycle, load on the car, all are having cyclic load, and all the parts will have endurance strength, whether it can withstand for a long period of time or cannot. Okay, this is table 817 for fully corrected endurance strength for bolts and screws with roll threads. Okay, this is the grade O class, this is the sign range, this is the endurance strength. Okay, you see it is increases within the value. So you see here ISO 8.8, ISO 9.8, 10.9, 12.9. So the value become increase. Okay, the value become increase. So the higher grade, meaning the higher strength it can withstand. Okay, and the bolt size is also bigger. You see here, this is if you remember, there is a video I made on how to write the size for the boat. For example, M16 and 5, okay, meaning that the size of the boat itself. M16 is this size 16, and 36 in bigger, this diameter of the boat itself. Okay, fluctuating force for general case with custom preload and external load on a per load basis, fluctuating between load minimum and load maximum. The boat will experience fluctuating force such as this is FB, fluctuating bolt. B stand for bolt. CP, stiffness of the bolt. P is the minimum load. Okay, minimum external load. F1 is the preload. Remember, preload is the load given by you when you are wrenching the bolt to become tighten. So the maximum that you can go, it is the initial load, initial force given. Okay, so what is a fluctuating force actually? What is a fluctuating force? Okay, so the meaning, if I translate into a graph, fluctuate meaning that go up and down, up and down, up and down. Okay, okay, this is the maximum, this is the minimum. This is if I translate into a graph. Scenario I given to you like a car, okay, like uh, imagine a car is moving, okay. When car is moving, the force in the car one is fluctuate all the time, okay. Imagine a fan, okay, your table fan, okay. When table fan, okay, the force fluctuate every time, and the bolts in that uh the bolt that connected to it, the force fluctuate, come front back, front back, front back, up down, up down, up down, all the time. Okay, that is called the fluctuating force, meaning that it will endure minimum force and maximum force all the time, repeatedly all the time. This is called the fluctuating force. If you remember, there is a video on the shaft. I explained about alternating force in the shaft. Remember, the bolt itself is like a shaft, and then it will endure alternating stress. Okay, minimum and maximum all the time. Okay, meaning that you can imagine anything: a motorcycle, a car, bicycle, table fan. Okay, all that are moving, all the force will be fluctuate all the time. Okay. Like I give you example like this. I attach this screw into this power tool that I have. You can see it going up and down, up and down, up and down all the time. This is called the, okay, up and down all the time. This is called the fluctuating force, meaning that we'll go up, the force will go up, the force going down, up and down, up and down all the time. This is called the alternating stress. Okay. And then mid-range stress experienced by a bolt, because the bolt itself is the shaft. If you can remember the slide for video on the shaft in when I describing on this topic, is the same. The bolt also have mid-range. This is the alternating stress coming like that. This is the mid-range stress at the middle of the bolt. Okay, middle of the bolt, middle of this bolt. Okay, so this is the mid-range stress experienced by a bolt. Because why mid-range is important, because the bending stress happen at the maximum at at the middle. Okay, imagine you can bending this, you can bend this. Okay, the bend will happen at maximum at this point, at the middle one, usually at the middle one. Okay, this is called the this is why they are telling about mid-range. Okay, there is an equation on the mid-range. And the Goodman line. Also, there is a video on the Goodman line on shaft topic. Video on the shaft. The explanation is more detailed on that video. So, but just I want to explain a bit for you to memorize. The Goodman line uh, is talking about fatigue failure. There is an equation for it. This is load line. SA stress strength. S stand for the strength. Okay, this is initial strength. This is the alternating strength. Stress mid range slash initial, and the Goodman line arranging it become stress uh, for the endurance strength. Okay, SE stress alternating strength endurance minus endurance over ultimate strength. This is the mid-range strength. You can get the equation for the strength is like this. This is the equation for the strength. Okay. Uh, Goodman failure diagram. If you can remember Goodman failure diagram. This is the graph. Okay, and then graph you get this. Okay, this is the uh, strength. This is the ultimate strength. Okay, you remember in your material class, okay, about the stress strain diagram. Okay, whenever, okay, this is the stress strain diagram. Okay, stress over strain, and you get this is the elastic limit. Then this is where you get the value for E, the Young modulus. This you have learned in material class. Okay, so to get this diagram, if you see about the Goodman equation, it is like a theorem Pythagoras equation. 3, 4, and 5. This is like a theorem Pythagoras. Okay, if you see the equation, it has a equals to like that. Okay, power 2 b power 2 c power 2 square root of that, then you can get the equation. And whatever result that you get, if you get that result is beyond this line, okay, you get the result beyond this line, it shows failure. Okay, it will shows failure. You should have your result below this line. If you get the result up more than this line, it will show failure on that on that bulb. Okay, uh, on that bulb. So what does a Goodman failure diagram will show? It will show about the end result will be the diameter of the bulb itself, whether you want it to become smaller, whether you want it to become bigger diameter. Okay, this is the factor of safety. The same approach can be used for other failure codes. So uh, algebra is a bit more tedious to put in the equation. So the factor of safety is what you want to give the value for. The fatigue factor of safety is given by NF equals to SA over stress A, strength alternating over stress alternating. So this is the equation given by stress endurance, ultimate strength. In the end, you must know what is the ultimate strength of that material. In other words, uh, if your design, you want to put heavy load on your design, you should put more safety factor on that design. If, for example, you are designing a chair for kindergarten children, the children they age 3-4 years, and their average weight is only about 20 kilogram, kan? Okay, that safety factor of safety is 1. If you are designing the chair for adult 40 kilogram, 60 kilogram, 100 kilogram adult, okay, uh, you must put the more safety factor for that design, because your customer is a heavy person, kan? Okay, so that is the safety given by you. Also, you can calculate there is an equation to calculate the safety factor. Okay, fatigue loading. Usually, fatigue loading happen in a pressure cylinder. Most cases, okay, for most cases, when you are dealing with pressure cylinder, you are dealing with fatigue loading. Okay, pressure cylinder is a gas at your house. You put your, when you cooking oil, the gas you buy from that shop. Okay, it has pressure inside it. The gas itself has uh, the cooking oil itself, the gas itself, it has pressure in that cylinder. That's why most of the gas is made from steel. And okay, because the steel can endure pressure. Okay, inside the, can contain the pressure inside the gas inside the pressure cylinder. Okay, so let me draw a gas cylinder. Okay, cooking gas. Okay, from any brand. Okay, inside it is a gas. Inside this is a gas. Okay, when gas is full, okay, it is has the pressure maximum. Okay, maximum pressure when it's full of gas, meaning that you buy from the shop, the gas is full. When the gas is finished, okay, there is no gas, so the pressure will be minimum. Okay, minimum. So this is meaning of pressure cylinder. Okay, this is an example of pressure cylinder. So the bulb this pressure cylinder, for this case, the bulb is at the upper side. Okay, at the upper side of most of the pressure cylinder you can see at your home. Now, okay, there is some sort of like a bulb. Okay, when you are filling to the maximum, is the pressure to the maximum at the bulb, and when you are using until the finish of the gas finish, the pressure is the minimum at this point. Okay, in such cases, uh, the setting will be maximum P and minimum P at zero when the gas is finished. Okay, and this alternating stress is when it is moving. Maybe you are putting it under the sun. Maybe you are uh, experiencing extreme heat in your house. Uh, it will become like that. So this is called the fatigue loading on it lah. The load line relationship. We know the equation 840 can be viewed as the sum of alternating stress and the preload stress. If the preload is considered to be constant, the load line relationship between the alternating and mid-range stress can be treated as this equation. Okay, the alternating load, the mid-line stress, the alternating load plus the initial stress. Load line is load has unity and special case of the load line shown in figure 8.20. You can find where is the figure 820, meaning that is the load line relationship between them. Okay, this is the Goodman gerber and ASME-elliptic. Talking it both three these three is talking about failure criteria. What is the failure that will happen? Okay, this is the equation for them. Okay, for Goodman, for Gerber, and for ASME-elliptic. If you can remember, there is a video in the topic shaft talking about this Gerber, Goodman, and ASME-elliptic. It's all talking about the failure, meaning that when you are uh, there is even a question in the shaft topic that ask you to solve this question on Gerber, Goodman, and ASME-elliptic. You get the value using this equation. The value more or less the same. It's not the same, but it's more or less the same. Okay, this is the stress value, and then you get the graph for Gerber, you get the graph for ASME-elliptic, and you get the graph for uh, Goodman. All these three is close to each other. Okay, meaning that the the value that you get in the end you translate to become the size of the bolt itself. Okay, this is what they mean by Goodman, Gerber, and ASME-elliptic equation. And this is the failure criteria that I stated before. This is the load factor for Goodman, load factor for Gerber, load factor for ASME-elliptic. Okay. Uh, okay. So note that equation 845, 8 to 847 is only applicable to repeated load. If repeated load, okay, if KF concentration strength concentration factor is being applied to stress rather than endurance strength, we should to apply it to both alternating strength and mid-range strength. Otherwise, the slope load will not remain 1 to 1. Okay, 1 to 1. This is the slope. The slope. Okay, this is this slope. Okay, so if you put the value, you can get more or less the same, not the same, but slightly different. Okay, value, but all showing failure criteria on the board. Okay, and then this is the preload. Okay, if the desired alternating stress for equation 8 9 and the stress, okay, can be directly into equation 845 to 847, which is the equation in the previous slide. If you do the Goodman criteria, you can get the load become this is the equation. Okay, with preload, Fi is present. With no preload is 3, stiffness of the bolt is 1, Fi is 0, and it become this equation. What does it mean by no preload? Meaning that you have not clamped yet. The bolt is not clamped yet. Okay, this is no preload. Okay, so the need for preload is beneficial to resisting fatigue when load factor and load factor get greater than unity. For Goodman equation, beyond 1 is put upper round to the load F1. Okay, is cannot be achieved, and F is unsatisfactory. Use the Gerber or ASME-elliptic criterion to obtain less conservative assessment. If design is not satisfactory, additional bolt or different size of bolt may be called for. So this is the need for preload. Okay, you can calculate, meaning that before you decide what bolt you want to do, what bolt you want to choose, this is the equation given to you. Okay, this equation will help you to choose the correct bolt. And the last slide is the fatigue factor of safety. Bolt loosen are there friction device, cyclic load or vibration, as well as the fact that allow fastener to lose tension with time. How does one fight loosening? With strength limitation, the higher the preload, the better. The rule of thumb is that preload of 60% of full load is rarely loosened. Okay, if more is better, how much is more? Well, not enough to create. You use fasteners as feature strength. Alternatively, fastener looking scheme can be employed. Okay, so after solving the factor of safety, you should also check the possibility of yielding using the proof strength. Okay, meaning that if you tighten up your bolt tightly, okay, if you tighten it tightly, you should no concern about it become loosened, uh, because 60% of the preload percent of proof load readily loosen. It may lose because of corrosion, okay, because of fatigue failure, and much more. So the thing is, never use uh, do not make it as habit to use to reuse fastener. The fastener, do not make a habit to reuse the fastener, especially when you design that you made, you want to leave it for a long time. Okay, if that design is for open and close repeatedly, meaning that the application after a while you want to open it, then you can use uh, fasteners, recycle fasteners. Okay, like recycled bolt, recycled washer, and everything. If you want to make it stay for a long period of time, better use uh, the new one. Okay, so this is the factor of safety, meaning that you, in the end, you find the better bolt. Okay, better better bolt, better material for the bolt, better diameter for the bolt, and you should not be worried about anything. Okay, so that's all for this video. We'll see you in the next video doing some example 8.5. Thank you very much.